Hey, it's Tony from Adafruit, and in this video we're going to look at this board right here. This is the, let me get out of the light there. This is the Feather M0 Express. So it's a brand new Feather M0 that's got some cool features and is built specifically for CircuitPython so that you can run Python code on here. And we'll look at a couple neat features and extra things that this has compared to some of the other Feather boards that might make this really interesting. So we'll dive in. I'll show you how to load CircuitPython onto this board because right now it's kind of a brand new board and it just ships with a default kind of test sketch on it so that you can use it with Arduino. But I'll show you how to load CircuitPython on here, play a teeny bit with CircuitPython, but I've got all kinds of other videos that I'll put a link to in the description below so you can look at all the CircuitPython and MicroPython videos to see more details on how to use it with hardware. But we'll see how to load CircuitPython, and then we'll also briefly look at a neat little library that lets you interact with this memory chip that's on this board so that if you're using CircuitPython, you can store files on there. It has an internal file system, and you can also access those files from Arduino. So it's kind of neat in that if you use CircuitPython and then you realize you want to use Arduino for some other stuff, you can actually share files between the two systems using a little Flash library that we'll look at. So a couple things we'll dive into here and kind of get started with. So let's jump into the main view real fast. And I'm hoping that the power does not go out during this stream because we're getting like gusts of 50-mile-an-hour winds apparently pretty soon. So we'll see what happens. Anyways, so this is the board in the upper right-hand corner. This is the Feather M0. And let me bring this up right here. This is a guide, and I'll put a link to this in the description when this is up on YouTube, so look below and you'll see a link to this. But this is for the product, so it's the Feather M0 Express, brand new board from Adafruit. And it's called an M0 because it has the SAMD21 processor right here. So this is the same processor that's used in all of the other M0 boards. Things like the Feather M0 Proto board, the M0 ADA logger, there's the M0 with the Wi-Fi radio, the Wink 1500. Lots of fun boards have this. It's based on the Arduino Zero, which was this SAMD21 based Arduino. Really nice processor, has more memory and more speed than your typical Arduino, but still a pretty low cost board. And what makes this one special, so what the Express means in the name right here, because we already have a Feather M0 boards, and if you've seen some of the videos I've done, I've shown how to load CircuitPython onto those boards. But the one big difference with this board is this little chip right here. So this is actually an extra thing that's only on the Express boards. It's a little flash memory chip. So this is just like the memory that's on the processor. So the processor itself has 256 kilobytes of flash memory, which basically that's memory that you can write to and that will be remembered when it's powered up and powered down. That's where you store your code. So when you write an Arduino sketch, it gets stored into that 256K of memory that's on your processor. That's also where the MicroPython or CircuitPython code is stored. So things like the firmware itself, like the actual Python interpreter, has to fit within that 256 kilobytes memory. But then also a little bit of that memory is taken up to say, here's where your Python scripts go, because when you write a Python script, it's a text file, and that has to live somewhere. And so on the M0 boards, all of that lives together on that 256 kilobytes of flash memory on your chip. Now the problem is MicroPython and CircuitPython firmware needs a lot of space because it needs to build in all of the potential functions that you might call, because it's a dynamic language. It doesn't know until it runs a program whether you're going to interact with neopixels, maybe you're going to talk to the pulse width modulation hardware on the board, maybe you're going to talk to the analog to digital converter, all kinds of different peripherals you might talk to. All of that code has to be available and on the chip so that when your Python program says, give me an analog to digital converter reading or set the pulse width modulation output to this value, it's got to call that code. It has to be there. Whereas in Arduino, it can actually be a little bit smart sometimes and realize, if your sketch is only using pulse width modulation and it's not using the analog to digital converter, it might not even compile in the code to talk to the analog to digital converter, so that can save some of the space. So the tricky thing is balancing how many features you build into the CircuitPython or the MicroPython firmware versus how much space do you leave for the programs that you want to use, because all of the space that's not taken up by the MicroPython firmware is what you have left for your Python programs. And on the M0 boards, what we've generally done is taken 64 kilobytes and given that to you, the user, for your Python scripts. So you can store things like your main.py, any libraries that you want to put on the board, other data files, things like that. You just have 64 kilobytes for that. And then the MicroPython firmware, the CircuitPython firmware, has the remaining space, like that 192 or so K of space available. So that's a little bit limiting, unfortunately. As we've started to add more features to CircuitPython, we've run into a lot of problems where it's like, boy, it'd be really cool to add things like infrared LED support, like IR code sending and receiving, but we don't have the space maybe for that necessarily. So that's where that little flash chip comes into play, this thing right here. So this is a 2 megabyte flash chip that's connected to the SPI bus. So it's just another SPI device. It's used the serial peripheral interface, and it's connected to the SAMD21 microprocessor. So it's just an additional set of memory and a significant memory upgrade. So 2 megabytes, that's quite a bit more. I think that's 8 times or so more space than what's on the microprocessor itself. And that's really cool because with CircuitPython, what we can do is say all of your Python scripts and code lives on that 2 megabyte flash chip, and then all of the CircuitPython firmware lives on the 256 kilobytes of microprocessor flash space. So that gives more space for CircuitPython code. The firmware can add more features and more functionality into it. And then it gives you more space for your Python scripts, a lot more space. So with 2 megabytes, you can store quite a large program on there, but what you'll end up really storing, I bet, are probably a lot of libraries and data files, external things on there. So that's really handy. And you might wonder, well, could you also use some of that 2 megabytes to store like an even bigger CircuitPython firmware, like a 2 megabyte size one? And you can't really, unfortunately, because when the processor runs, it runs code out of its flash memory. And as far as I know, there's no way for it to run code off of an external chip, because when it actually gets your Python program from this little flash chip, it has to talk to it just like a SPI device. And in fact, if you really wanted, you could buy a little flash chip like this, put it on a breadboard or wire it up to, put it on a custom circuit board and connect it to a SAMD21 microprocessor, or even an Arduino Zero or Feather M0, and you could make your own version of this board. Just connect a flash chip over the SPI interface for this. And actually, I think we have a little SPI chip in the shop now that I'm thinking about it that uses a breadboard compatible interface. So you could build your own, but the tricky thing though is that these processors aren't meant to run their code off of that flash chip. It's more for getting data off of that flash chip, and that data might be a Python file that's then loaded in memory and run with CircuitPython. So that's the big standout feature for the Express boards, is the addition of that flash memory, which will give you more space for program code, and then more space for your Python code also that you're putting on here. There's also one other little change. There's a little NeoPixel right here I'll show you a little bit more about this. So it's connected to the processor, and we actually use that to do things like show some status info. And eventually, I think we'll probably let you control it yourself, like if you want to have a little status indicator for your hardware. So it's a handy little thing to add to the board, and we'll look at what that thing does. So let's kind of get started. Like I said, it's a brand new product, and everything is still kind of in beta for some of this, CircuitPython in particular. So, we're still developing the firmware, and lots of things are changing. So keep an eye on kind of the latest news for it. Check out, we also have a MicroPython newsletter. So if you aren't subscribed to that, check out adafruitdaily.com and subscribe to that, and you can keep on top of all the latest news for things that we're up to in the CircuitPython and MicroPython world. Anyways, this is the guide. So if you get this product, you'll want to check out this guide. It comes just as a feather board, and you can solder some headers onto here so you can connect all the feather accessories to it. Things like the different wings that we have. There's the nice little LED matrix, there's LED backpacks, there's CharliePlex display, sensors, motor drivers, all kinds of fun stuff that's compatible with this. And it's pretty straightforward. Just solder those headers on, and you don't even have to solder them on. I don't have them on this board. But it's probably useful if you put headers on this board. And then once you have it together, then there are two things you can do. So by default, the board does not right now come with CircuitPython installed on it. So it just comes with a test sketch that's kind of validating all the hardware. In the future, it might come with CircuitPython on it, but for now, you'll need to load it manually. Or you can also load it and use it just like an Arduino M0 board or a Feather M0 board. So just like you've used the Feather M0, you can use this in the Arduino IDE. You can write code using Arduino. You can use all of the Arduino libraries that support this board, and even an extra one that I'll show you at the end of this to access some of the flash memory. But it's just like any other Arduino board. And so this guide walks through how to set up the Arduino IDE. So you add this extra board URL, and then this will make the board available in the board manager so that you can install this and use it. We'll look at this later in the video. But what you're probably interested in is how do you get CircuitPython running on this board? And so in this guide, there's a great description here of how to load the latest version of CircuitPython onto here. And there are two ways to do this. This is another thing that's a little bit different about the Feather M0 Express board. It's shipping with a bootloader that's more advanced than the bootloader that we've shipped on the other M0 Feather boards. And this one's actually really cool. It has a special USB drive mode. So if you've loaded CircuitPython onto a SAMD21 or a Feather M0 in the past, you've probably had to use a command line tool, this BossSC tool that just talks to the chip and sends it all of the data. It works, it's fine, but it's a little bit tricky sometimes, and you have to install some software to use it. So we were looking at, is there an easier way to use this with custom firmwares? And I'll show you something neat. So what you want to do to load the CircuitPython firmware onto here, first you need to download the latest version of the firmware. So from this guide, it links to this page right here, which is the releases page for CircuitPython. So look for the latest release. Right now, 0.9.3. The latest release should be at the top of this page. And you want to look for all of the files that are here. And there's one file in particular that you want. So look at Adafruit's CircuitPython Feather M0 Express. So that's the board that you're looking for. And you notice there are other boards. There's like the M0 Adalogger, the basic M0, the Huzzah, that's the ESP8266, the Arduino Zero, so all kinds of other firmwares. But look for the Feather M0 Express, and then notice there are two files here. There's a .bin and a .uf2 file. So the .uf2 is what you want for this special USB drive programming mode with the bootloader. So click this, download this file. I've actually downloaded this one ahead of time, but grab this .uf2 file, and then I'll show you what you need to do. It's really simple and easy. Oops, let me load up the file here. So I'll just show you, here's that .uf2 file right here. And then to load the firmware, so forget, if you've used that BossSC tool, forget everything you know about that. It's way easier now. We're gonna plug in the board, and after you plug in the board, you want to double tap the reset button in the corner right here. So that reset button, you just press it twice real quickly, and you'll see this red LED will start to pulse. It's going on and off. That's just telling you that the bootloader is loaded. And you might notice this thing just popped up right here. So I have a new drive that just appeared, and it's called Feather Boot. And this is really cool. So this is the bootloader for this SAMD21 processor. It looks like a USB drive. So I've connected it to my Mac computer. It looks like a USB memory stick. And it actually has, I can download this current .uf2. This is the current firmware that's loaded on this chip. Maybe not super useful to you right now, but if you're debugging or something, you can actually pull the firmware off the chip, which is kind of handy. But you can also say, okay, I want to put firmware onto this chip. So I can take this .uf2 file that I downloaded earlier, that Feather M0 Express UF2 that has CircuitPython firmware, and all I have to do is just drag it onto this drive, and it's going to recognize that it had a UF2 file sent to it. It just programmed it, and you might have seen the red LED was just flashing really quickly. That's just telling you that it's programming the firmware that you copied over. And then you might have just noticed this little CircuitPy drive just popped up. So that's cool, and that's a really good sign, because what just happened was the chip just reprogrammed itself with the CircuitPython firmware by just dragging that UF2 file onto the board in that bootloader mode. It reprogrammed it, and you didn't have to have anything installed. You don't need the BossSC tool installed. You could do this on a Chromebook in theory, or any board, anything that has USB drive support. This should work on it. So that's pretty cool. And just to show that this really is CircuitPython on here, let's connect to the serial REPL so it shows up as a USB device, 115200 baud. And by the way, if you're on Windows, you'll need to install a driver to access the serial REPL, look at the guide. We mentioned there's a link to an installer tool that gives you the driver that you need for this. But I open this up, and this is showing me the REPL. If I press enter, I've got, hey, hello world from CircuitPython. So that's pretty cool. And so now this board is running CircuitPython. Now you might have noticed the NeoPixel was doing something. It was lighting up. It was showing different things. So let's, with this serial REPL open, I'll maybe explain what the NeoPixel is doing. I'm going to press Control D, D as in dog, to reset the board. So it's back into kind of its normal startup state. And this is kind of cool. So you can see the pixel is pulsing this green color. And that's telling me that CircuitPython is running, and it's in its auto reset mode. So it's waiting for me to save a file onto this board, like a main.py script, and then it will run the contents of that script. So let's do that. We'll keep our serial REPL open, but I'm going to open a new terminal window, and I'm going to go to the CircuitPython drive. And if you're on a Mac, it's in the /volumes folder. So under here, you can see I have the CircuitPy directory. So this is the CircuitPython drive, and there's nothing in there right now. But these are all the files that would be on the CircuitPython board. And if I want to, I can say, let's edit my main.py, and let's just have it print out, hello world from CircuitPython. And let's save that. Oops, I pressed the wrong key right there. Say Control Alt, there we go. Okay, so I just saved that, and this is cool. So now if I go back to the serial REPL, notice this text is new right here. So it noticed that I saved the main.py file to the board, and it ran it. So you can see here's the main.py output, hello world from CircuitPython. And you might actually see there's sometimes some noise from the way I have my USB cable set up here. It sometimes sends some noise that kills this connection. So there's sometimes a little bit of wonkiness. Hey, it's a little bit of beta stuff. But that's pretty cool. And it ran my script when I saved it when the LED was in that green pulsing mode. So that's telling me I'm waiting for you to save a file like a main.py, and then it's just going to run it. And so whenever you see that green LED, then you know it's in that auto run mode. Now you notice it just jumped into this white color, and that's basically if I touch anything, if I send any input in the serial REPL like I just did a moment ago, that actually turns off that auto run mode. And so you see the green pulsing goes away, and it just turns it white right now. And these colors, who knows, they might change in the future. But for now, these are the colors that we're showing the status with. So it's just a good thing to kind of know, so you can understand when you plug a board in, you don't necessarily have to open up the serial REPL to look and see, okay, like what mode is the board in? Is it ready to run files? Or if I saved a file on here and I don't see the output or it doing anything that I expect, I can look and see, oh yeah, okay, it's not flashing green, so it must be waiting for me to type in commands and things at the serial REPL here. Whereas, if I reset the board again, it's in that green state and it's waiting for me to save a file and it's going to rerun it there. So that's pretty cool. You might also notice too, like if I copy a file onto the board, and I don't know if I have a good example to show with that. I don't know, let's try something. Let's copy our CircuitPython firmware onto the board. Well, actually here, let's copy the zip file on the board. The zip file doesn't really mean anything, but this will just demonstrate what's happening here. So see how the LED is flashing red and blue and different things like that? So what happened there was when I just dragged this zip file onto the board, and if I look at the board, you can see that zip file is on there now. This flashes red to indicate that there's something being sent over the USB connection. So like a file is being transferred to the board. So it's just kind of good to know. It's like a status indicator to say, hey, something's happening. You're sending data to the board so that you can kind of know, like, if you see this thing flashing red a lot, something's writing to the USB or maybe you're reading the data from the USB on the board. So just another handy little indicator there. And you can see after I copy that zip file, because it was pulsing green before, when it finished copying that zip file, the board reset and it ran the main.py again. Even though I didn't copy a main.py file over, just anytime I write to the board, it's going to reset when it's in that pulsing green mode, the auto run mode for this. So that's pretty cool. And then again, if I press something in the serial terminal here in the REPL, that turns off the auto run mode, turns white, And so now, you know, I copy files over, it's not going to rerun. I have to manually either reset the board or like log into the serial terminal here and run things itself. So that's pretty cool. Those are the basic features of the M0 Express board. So it's just like an Arduino Feather M0, but it has that extra flash chip. And so that's the cool thing. I mean, you can notice, you know, on this CircuitPython drive, because again, with CircuitPython on the M0 boards, we make them appear as a drive on your computer. Notice, you know, I copied over this 93 kilobyte zip file. You can't do that on a basic M0 board because, again, we only give you 64 kilobytes of space for your user file system. That's where you store your Python scripts. But on the Express boards, you've got up to 2 megabytes of space. So that's pretty cool. You can copy larger files onto the board. You can write more advanced Python code. Now, there is a limit, though, because whatever Python scripts you copy onto the board still have to be able to fit into the memory of the M0 processor for it to run. So you can't write like a 2 megabyte large .py file and run that entire file. It's only, you know, you have to break things up into smaller files and import just small bits there. But it is still kind of nice that you can have a lot of libraries copied onto the board. And if you're not using all of them, you're not going to infer any memory costs. It's only just, you know, you import the modules that you care about for what you want to use. And then it's also handy too in that you can use that to store data files and read them from your Python script, for example, like, you know, maybe store images or text or things like that. And as long as you don't try and load the whole thing into memory, then you can still access it all from the board. So, okay, so that's pretty cool. Let's look at one. Oh, okay, let's see. Scott was mentioning, let's see, if I make a syntax error, let's see. Oh, right, I forgot there is a neat thing that we do. So let's edit that main.py. First, I'm going to reset the board. So I'll show off one other feature that Scott just reminded me of. So I'm in the auto run mode. You know, it's flashing green. It's telling me, hey, save a file and I'll run it. Let's go back and edit that main.py that's on the board. And let's put a syntax error in here. So let's forget to put a parenthesis in here. And let's write this out. And now let's see what happens. So, okay, so it just ran the board. It just ran my script. And it just failed. So now I have my serial REPL open, and so I actually saw, you know, it ran main.py. It found this syntax error, but you can see it's actually flashing. So it's, if I remember correctly, it's flashing out the line number that has an error. So line 3, syntax error, invalid syntax in my main.py. And so you can see those 3 flashes that are saying, hey, something's wrong. You know, I tried to run your script and SOS, you know, you've got an error there. So cool little indicator. I mean, this could give you a workflow where, like on a Chromebook or even an Android device or anything that has just USB file access, as long as you've got a text editor, you can write code, copy it onto your board, and then see if it, you know, if there was an error or if it ran successfully. So that's pretty cool and pretty handy. And then, you know, just to show that this works, if I edit this file and if I fix that error, so if we put the parenthesis back and write the file out again, then you see it runs, and then we're back to the pulsing green mode. So it ran my script, and if I go back to my output, you can see, yeah, it ran my main.py and everything worked great there. So kind of cool thing, neat little feature of CircuitPython. Again, because we've got that little NeoPixel on here, we can do fun stuff like that. So, okay, so that's one thing I wanted to show, and then real quickly, I'll show a neat little integration. So again, like I mentioned, you can use this board with the Arduino IDE. So you can program this just like any other M0 board, and, you know, use all the Arduino libraries. So this is great in that, you know, again, like CircuitPython is still in beta. You know, we're still adding new features to it. It's you know, it's a growing thing. So you might run into limitations and realize, oh, I want to do this project, but maybe I can't do it in Python yet. So that's fine. You can still use this with Arduino. So I'll just show you real quickly some Arduino integration with this. And again, check out the guide. So it walks through how to set up the Arduino IDE. You have to add this board to the board manager URL and then install the board. And it depends on Arduino's SAMD package. Everything's in the guide here. Just follow the guide. It'll show you how to set it up. I've done that ahead of time on this board. And just to show you, you know, eventually you'll get this Adafruit Feather M0 Express in the board manager, like I have right here. And I can program this just like any other Arduino. Although one little note, if you're in CircuitPython mode and you want to go back to Arduino, what you want to do is double tap the bootloader, or the reset button rather, to get into the bootloader mode. And you'll notice it goes into that drive mode with the Feather boot. And then the cool thing is this bootloader supports both the old mode of using the Boss C tool, which is what Arduino uses internally, or the drag and drop feather boot drive method. So you can use either method, it's fine. You don't have to do anything special. It's just you double tap the reset and it's waiting for either boss.c or the drive.uf2 file. So Arduino doesn't use the uf2 file stuff, but it uses that boss.c tool internally. So I can flash this blink sketch if I want. So I just make sure it's pointed at my board, and then I press the upload button. It's going to compile. This is your basic. It's going to blink that little red LED right there in a moment here after it uploads it. And so it's this is handy. You know, you can use this with Arduino IDE, just like any other Arduino board. All the libraries for Arduino you can use with this board that support the M0 boards or the Arduino Zero. So it's doing its flashing thing. It just finished, and there you can see the red LED is blinking. So that's all goodness. Okay, so there's one cool thing. Like I mentioned, so CircuitPython, when you load CircuitPython onto your board, it takes that little 2 megabyte flash chip and makes it a file system. So you can store Python code, you can store data files on there. Now, one neat thing would be like, you know, okay, let's say I do a little bit of things in CircuitPython, and then maybe I go back to Arduino, and can I access those CircuitPython files from Arduino? And it turns out, yeah, you can, actually, using a new little library that I created that accesses the flash chip on this Feather M0 Express board, and it gives you a couple ways to access that flash chip. So you can access the flash chip at a very low level, and you can, you know, just read and write blocks of flash memory. Again, it's just a flash chip connected to the SPI bus, and so if you read the data sheet, you can talk to it and do whatever you want with it. You know, it's yours to control. But we've made a nice little library that wraps up some kind of common functionality and simplifies it a lot, because in some ways that flash chip is almost like a little SD card, you know, a little micro SD card where like some Arduino boards support connecting a micro SD card to it and then accessing the contents of that card through a real simple little API that Arduino has. So, you know, you can open a file and you can write to it and read from it, or you can list all the files in a directory using this SD card library. So I took that SD card library interface, like the exact same functions and objects and things that it deals with, and just plugged in an implementation that talks to our 2 megabyte flash chip right here. So you can store files, you can read files, you can write files, you can create directories, you can delete directories, you can do pretty much anything you can do with your computer file system on this 2 megabyte flash chip from Arduino, which is pretty cool. And then we went a little bit further also and made it compatible with the file system that CircuitPython uses. So even though I just loaded an Arduino sketch on this microprocessor, because I had CircuitPython loaded on here before I had this sketch, it actually formatted my flash chip with a CircuitPython file system. It has that main.py file that I was editing before, you know, that prints out hello world. That's on there. It has that zip file that I copied over that was just demonstrating the file access. All of that is still on the flash chip, because when you reprogram this board in Arduino, it's only reprogramming the SAMD21 microprocessor. It's not going to touch your flash chip unless you run some code that talks to the flash chip and reprograms it. So that's kind of a cool, handy kind of feature, in that, you know, as long as you don't mess with that flash chip, you can still access it and the contents of it from Arduino. So to do that, I'll show you, there's this library right here, this Adafruit SPI Flash library, and eventually we'll put this into the guide, the CircuitPython or the M0 Express guide. So this guide will be updated a little bit later to have a little bit more detail about how to install this. But I'll just run through real fast in this video. This is an Arduino library, so just like any other Arduino library, eventually this will be in the library manager and you can install it from Arduino's library manager. But for now, I'll show you the manual install. So you download the zip file for this, and that will give you a file that you then, let's see, I'll show you right here. So here's the zip file. You want to open the zip file up, and this is going to give you a directory. You want to rename this and take the -master off the end of it. That's just something GitHub adds to this. So delete that from the end of it. I've already done that, and so you can see I have this directory right here. And inside of here is just the code for this library. So this, you know, it's just some classes and headers and things. So you want to copy this entire directory, so this SPI Flash directory, we'll copy that. and I want to put this into, and it depends on your operating system. I'll put a link to a guide that we have that's how to install an Arduino library, because you need to copy this into your Arduino libraries folder, and it differs depending on if you're running Windows or Mac or Linux. On Mac, it's in your Documents, Arduino directory. There's a Libraries directory right here, and this is where you want to copy in this Adafruit SPI Flash folder. So I've already done this ahead of time, but copy that folder into this Libraries directory, and that will make it available to Arduino. And then close and reopen the Arduino IDE if you had it open already, just so that it reloads and it should find that library. But I already had it loaded. And then you should be able to see in the examples, there is this SPI Flash library. There we go, Adafruit SPI Flash. So this has a bunch of examples inside of here. So there's FATFS, CircuitPython, data logging, format, full usage, print file, and then flash erase. And I'll mention real quickly kind of what all of these do. But the one that we're most interested in this video is the top one, the FATFS CircuitPython example, because this is an example that shows that integration where if you have a flash chip that CircuitPython has formatted and written files to, or maybe it hasn't written any files to, but if you've run CircuitPython on this board ahead of time, then you can use this FATFS CircuitPython example to read files or even write files back to that CircuitPython file system. Now the other examples, the FATFS data logging, format, full usage, and print file, these actually use the flash chip just entirely on its own for Arduino. So these are not compatible with CircuitPython, but these just show, maybe you're not using CircuitPython, but you still want to read and write files to the chip. You can look at the FATFS format example. So you need to format the flash chip. It's just like a USB drive. When you plug a USB drive into your computer, you need to format it ahead of time. So you run this format sketch once, it will write a blank file system to the chip, and it warns you it'll erase anything that was on the chip, so be careful. But this, you run this once, that will give a blank file system. Then the full usage example walks through all of the different ways you can use this library. So it shows you how to create directories, how to check if a file exists, how to create files, how to write to a file, how to read from a file, how to delete directories, delete files, pretty much everything you could want to do. It has an example in there. And again, this is all using the exact same syntax and API calls as the Arduino SD card library. So if you've ever used the SD card library, this should look really familiar. And there's just a few small things that change based on how you initialize the library, basically. Now the print file and data logging examples, these are just more simplified examples. So data logging will just show how to append a new line of data to a file. So the scenario is you've got a sensor connected to your board and you just want to log like every minute what's the humidity or what's the temperature. And so look at the data logging example. This is a great, real simple example. It just opens the file and just writes a new line every minute to it. And then the print file example is a simple example of reading a file. So you run this example and it will open the file that was previously created from the data logging example, and it'll just print it out to the serial monitor. So this would be a good example of, if you were data logging before, and then maybe you've got some other sketch that runs and reads in your data file and does something different based on that. So those are the examples. And then flash erase, this is kind of the big sledgehammer for if something goes wrong with the flash chip, like maybe the file system gets corrupted, you can run this example and it will just completely erase everything on that flash chip. So if you had CircuitPython code on that chip, it's gone. If you had stuff that you stored with Arduino, it's going to wipe that out. So it's handy to have just to reset the chip and get it back into a known state. But again, be careful. It warns you. You have to confirm and say, okay, I want to delete this chip before you run it. But like I said, let's look at this CircuitPython example. So like this example mentions, you need to be running CircuitPython on your board ahead of time. So make sure that you've loaded CircuitPython, and maybe you've created files with it, or maybe you're going to create some files with this example. So you definitely, that's one step that you need to do before running this example. And again, this only works with CircuitPython firmware. So the way that this example works is it's not going to be able to read the file system if you used some of the other format examples. So this is just for integrating with CircuitPython, because the file system is actually a little bit different if you use CircuitPython versus if you use it just in Arduino, like using that FATFS format and FATFS data logging example. it's slightly different in how it creates the file system. So just be careful about how you use the examples here. But like this mentioned, so what this example will do is when it runs, it will look for a boot.py file on the CircuitPython file system. If it finds that, it'll print it out. And then it'll look for your main.py, and if it finds that, it'll print out the contents of your main.py. And then it'll make a new file, data.txt, and it'll just add a line to it. I think it just adds a hello world line to it. We'll look in a moment here what that looks like. But this is just showing basic usage of reading a file that CircuitPython had written before, like the main.py file, and then also writing a file. So writing that data.txt, which I could come back later and I'll show, we'll reload CircuitPython and show that I can read that file now, which is pretty cool. So, okay, so to use this example, you want to load it up, and if you're using the Feather M0 Express, there's nothing that you need to change. It's all configured and ready to go. But just to show you how this library works a little bit, you create this Adafruit SPI flash object, and you have to tell it how to talk to this, the SPI flash chip. And this is using a hardware SPI interface that's built into the Feather M0 Express board. But this is flexible. Like I said, you could wire a SPI flash chip up to an Arduino with like a software SPI connection, and this shows like an example of connecting that. And so you don't have to use the M0 Express in this case. And then the next thing is this magic line right here, where this creates an Adafruit M0 Express CircuitPython object, this object or this type of object. So this creates an object called python-fs, and it needs to be told the flash chip that I created ahead of time. So basically you create the interface to your flash chip. That gives you all the low level, like read a block, write a block functionality to talk to the flash chip. And then you pass that to this CircuitPython M0 Express wrapper class, which then takes that raw flash chip and gives you that simpler interface. It gives you like the file and folder interface. So instead of reading and writing the raw blocks of flash memory, you're reading and writing files, which is what you as a user probably want to do. Like, unless you're really hardcore and you know how to write a fat file system in CircuitPython format, you probably want to use this wrapper class. Okay, so in the setup is where all of the magic happens for this sketch. So it waits for you to open the serial port right here. This is just so that it doesn't immediately run and you miss all the output. So we'll load this on the board, and then it's only when you open the serial monitor will you actually see this start to run. The very first thing it does is it initializes the flash chip right here. So it calls the flash chip begin function, and it just makes sure that that succeeds. And then if it succeeds, it goes on and it prints out, it calls this flash get JDEC ID. This is just getting this ID that's burned into the flash memory. It's just a good thing to check to make sure that it can talk to the flash chip. I'll show you, this should come back with a constant, this OX140150, I think, value. So if you see something other than that, then something's wrong. This is useful like if you've wired a flash chip up yourself. You want to make sure that it can actually talk to the flash chip. Okay, and then the next thing is it calls the python-fs object. So remember, that's that little wrapper object right here that wraps around the raw flash memory. So we have to call the begin function on there, because that will actually load the file system that CircuitPython had created ahead of time. And if it returns true, then everything's good and the file system is loaded. If it returns false, then something went wrong. And again, like it'll tell you like, hey, make sure that you loaded CircuitPython ahead of time, because CircuitPython has to create that file system before the Arduino sketch can load it and start using it. And then once it finds that, it's just going to do a couple things. So it's going to look to see if your boot.py exists. So this is where the high-level functions come into play on this python-fs object. So you can call this .exists function and just pass it the name of a file, and it's going to look for that file. And you can pass in like different paths here. Like if there's a directory called foo, you would just pass in /foo/boot.py, just like you're using an SD card. You can have directories and things like that inside of here. And so this is going to return true if it exists. If it exists, then it's going to create a file object by calling the open function on that python-fs object. It's going to tell it, okay, open up that boot.py file and open it in file read mode. So just like the SD card library, there's a file read and a file write mode. So depending on how you open the file, that's what operations you can do with it. Once it opens the file, then it just loops through, just like with the SD card library, while there are bytes available. So while it's not at the end of the end of file, it's going to read a single byte at a time and then print it out to the serial port. So it's going to do that for your boot.py, and it's going to do that for main.py. And then we'll come back in a second, but it's also, after it prints out the boot.py and the main.py, it's going to open a file, this data.txt file right here, but it's going to open this for file write mode. So this is going to show an example of how to write a file onto the CircuitPython file system that later on we can go and read in CircuitPython. So this opens a data.txt file, and the way the file write mode works is just like in the SD card library. It opens it in append mode, so that if the file exists, it's going to open it and go to the very bottom of the file and start adding new data as new lines at the end of the file. So it's not going to delete what was previously in the file. If the file doesn't exist, it will automatically create it, and then it'll just start adding new data to it. So again, like the SD card library, this is more suited towards data logging scenarios. Like usually you just want your sketch to get a file and just start adding new data to it. So that's what you can do. But you can get much more advanced, and actually if you look at the full usage example, so if I look at in the SPY library, there we go, SPY Flash. So check out the full usage example. This shows many more functions that you can use on here. So like you can make directories, you can, let's see, this shows like writing different objects out to the files. You can delete things, lots of functionality. But notice at the top, this talks about how this has the same interface as the SD card library. So you can look at the documentation for the SD card library, see the functions that it exposes, and this library has the exact same functions built into it. But then this also mentions, I think I mentioned it in here, maybe it's not in this example, but this library is built on this really excellent library called FATFS, the Fat File System. It's a small Fat File System implementation for small microcontrollers, and it's actually the implementation of the Fat File System that MicroPython and CircuitPython use. We've just taken that and put it into an Arduino library. It's a really excellent library created by this Elmchan software, I want to say. So check that out, and you can actually access that FATFS at a very low level yourself. If you look at the format example in the library, let me go down to that. Yeah, here's the format example. This actually shows how, so this is a link to the FATFS API reference. So, if you use the Arduino Flash library here, and if you run into limitations or you want to do more stuff, you can access the FATFS library yourself and call all of its functions and use it at a low level. And so this format example actually does that. So it's calling the functions in the FATFS library, like there's this fdisk function. This is a part of the FATFS library. And so you can see it's a little more prickly. This is a C library, so it's it's maybe not as nice to use as Arduino libraries that try to hide a lot of the complexities of like creating buffers and passing around pointers and things like that. So it's a little more advanced, but it gives you as much access to the chip as you want. So you can do anything with this. So there are more advanced ways to open files and things ultimately. But again, if you're just doing simple things like data logging, adding new sensor readings, look at the examples we have, like the data logging example. That just shows the basic simple usage for this. Anyways, okay, so let's come back to that CircuitPython example. Let's run this on our board. So I'm gonna make sure I have my M0 Express board selected. It's available there. So let's press the upload button and let's see what happens here in a second. So this is gonna upload the sketch. And again, this should print out the boot.py, the main.py, and then create a file and add a line to it. So just upload it to the board, and then I need to open the serial monitor, and I want to open it at 115200 baud is what you really want to open it at, but it defaulted to 9600. It's fine. If you don't see any output, then change it to 115200 baud. And actually here I will reset the board just to show what's happening. So I reset the board, and then I'm going to reopen this in the serial monitor. So you can see this prints out all the text as soon as I open the serial monitor. So it found, here's that JDEC chip ID. So you want to see a value like this, 140150101. That just means that that's the ID that's burned into that flash chip. If you see a value like FFFFFFF, like all Fs, that's bad. That means that you can't talk to the flash chip. And so you probably have something wrong right here, like with this connection. So by default, it's trying to use the hardware SPY connection on the Feather M0, but maybe you've wired it up to an external flash chip, and so double check all those connections. It's not able to talk to the chip correctly if you see a value that's not this 1401501. Okay, so this is cool. So I can see it mounted the file system. So that's got through to this line right here. So, you know, we call that python-fs.begin. That succeeded, so that's good. We've mounted our CircuitPython file system. No boot.py found, which is okay because there was no boot.py on this board, so that's what I expected. So you can see this checked to see if that existed. It didn't find it, so it printed out no boot.py existed. But this is kind of cool. So now it said printing main.py, and you can see here's the contents of that main.py file, print hello world from CircuitPython. If you remember, about 20 minutes ago or so, maybe 30 minutes ago, I wrote that file onto the board when it was running CircuitPython. And so now my Arduino sketch is reading that main.py file from the flash memory chip that CircuitPython had written on there. So that's really cool. And that's what I wanted to show with this library is that, you know, if you use CircuitPython and then you go back to Arduino, there's a way to talk to the file system and still get files from the board. So that's cool. So that's an example of reading a file. And then it mentioned here, it wrote a new line to the end of data.txt. And so that's like we walked through before. So I created that data.txt file and then wrote, so hopefully there should be a data.txt file that says, hello CircuitPython from Arduino. And I think it should say it twice because I ran this sketch twice. So it should hopefully have 2 lines inside of there. So let's reload CircuitPython onto this board and let's see if that file exists. That'll be the ultimate end-to-end test. So I'm going to double tap that. Now it's in its bootloader mode. I've got my Feather boot drive again. So again, just like I showed before, let's load up CircuitPython firmware onto this board. So I'm going to grab that UF2 file. I will drag it onto the Feather boot drive. It's programming it right now. And then it just finished. And then here's the cool thing. So it just popped up now. Now CircuitPython is running, and CircuitPython exposes that flash chip as a USB drive. So if I look at this USB drive, hey, check this out. So we still have that zip file I copied over before. You know, again, none of that stuff is deleted unless you explicitly delete it. There's my main.py, and I should hopefully be able to see if I open this in, let's not use Xcode. That's a little bit heavyweight. You know, if I open this in the text editor, there's hello world from CircuitPython, so that my main.py is still there, just like we saw in Arduino. And then if I open up the data.txt file, let's see what's inside of here. So there we go, hello CircuitPython from Arduino, and it's in there twice, which is what I expect to see because I ran this sketch twice. Like it ran once when I opened the serial monitor at 9600 baud, and then I reset the board, opened it again at 11500 baud, it ran again. So that's how I got the 2 lines there. And so that's cool. So that was the line that was written right here from my Arduino sketch. So again, just showing that it's possible using this Adafruit SPI Flash library to talk to that flash chip and talk to the files that CircuitPython has written. You can both read files and write new files that CircuitPython can then itself read from your board. And I mean, just to show maybe another example, if I connect to the serial REPL on my board, so we'll say screen dev tty 11500 baud. So in the serial REPL, I can open up the files. Like if I import the OS module, or if I import the UOS module in MicroPython, uos.listdir, this lists all the files that are on the root of my board. So you can see there's that data.txt file. And then if I say data equals open data.txt, and I want to open it in read mode, then that's going to open the file. And then if I read all the contents of it, hey, there's my 2 lines. There's hello CircuitPython from Arduino, hello CircuitPython from Arduino. So, you know, I could do some kind of cool example here of like, maybe I have some Arduino sketch that runs on here and gets, you know, runs for a while and gets a bunch of data. And then I want to go process that data later, but I want to do it with CircuitPython. So I load CircuitPython onto here, and then it reads those files that I stored from the flash chip. So it's possible to do that using this SPI Flash library. So, okay, so that's it. I think that's all I wanted to show in this video. So if folks have questions, throw them in the chat, and we'll see if I can get to them. Someone mentioned, is SQLite 3 supported? That's a good question. So is SQLite supported in MicroPython or CircuitPython? As far as I know, no, it's not supported. Although one place to check would be in MicroPython's GitHub repository. There's a MicroPython lib project. And so this is basically a bunch of Python standard library modules, things like the SQLite module potentially. They've taken a bunch of Python standard modules and they've implemented them for MicroPython. And so if there is a SQLite module, it might be in here. But let's see. I have a feeling SQLite is pretty complex. Well, hey, there's something called SQLite. That doesn't necessarily mean that it's implemented. So let's just see. Oh, well, there is an implementation here. Now, I have a feeling, just based on the fact that it's using this FFI lib, this probably only works with MicroPython on Unix systems. I doubt that this would work on an ARM Cortex. Because MicroPython can run on your computer like a Unix-based system. And in those systems, it could use SQLite, because SQLite is just a dynamically linked library, so we could load that library up. Whereas on your ARM Cortex chip, you have no operating system, so you have no concept of shared libraries. If you try to take a Unix dynamic library, there's no way to load that code. There's no kernel to interpret it. So long story short, it doesn't look like SQLite will work on your microcontroller with MicroPython right now. But I bet in the future, because the basic idea, if you want to use SQLite, you probably want to store data. So you could still use files. You could create files and store data to them. Although you can't do that right now with CircuitPython, just because we don't let you write files to the flash memory when it's exposed with USB. Look in the future, we're going to think of some ways, because they're race conditions. If your script is writing to a file while your computer tries to write to the file, if those writes happen at the same time, you can corrupt the whole file system. So we don't let you do that. But anyways, long story short, the basic thing is there's no SQLite, but look for ways to persist data using files potentially. Like you can use the JSON serialization. So there's a JSON serializer built into MicroPython. You can throw any Python object into the JSON serializer. It'll give you a JSON string back, and then you can write that string out to a file, for example. So that's a very bare bones database, quote unquote. There's no indexing, there's no querying capability for that. So, but it wouldn't surprise me if in the future, with more powerful chips, maybe someone will take a crack at implementing a tiny little SQL database that runs on these ARM Cortex chips. That would be pretty cool. So, but unfortunately, yeah, no SQLite support right now for CircuitPython and MicroPython. Okay, I think that's it. That's all the questions I see. So I will wrap this up. We'll go back to the main shot. So again, this is Tony from Adafruit. Thanks a lot for watching. Check out youtube.com/Adafruit. You can see this video and all kinds of other fun project videos. Check out twitch.tv/Adafruit, and you can see me streaming these things live. I like to do a live stream usually every Friday. So this was the stream on using the Feather M0 Express board. So fancy new board from Adafruit. It's the Feather M0 plus that little SPI memory chip and NeoPixel that go really well with CircuitPython. So you can store more Python code, you can have more advanced firmware on this board because it's that Express board. So definitely check out that board and stay tuned for lots more CircuitPython and MicroPython stuff, particularly around this board, because going forward, you'll see this in a lot of other future boards. I don't have one near me, but there might be a Circuit Playground board potentially that might have a flash chip like that. So don't ask, it's not out yet, but there's some cool stuff planned in the future that's going to be using that Express and that extra flash memory that we have. So until next time, this is Tony from Adafruit. So click the like, the comment, the subscribe. Let us know that this is good stuff, and we'll keep doing content like this. So thanks a lot for watching. I'll see you later. Bye.